All right, so today we're going to start Chapter 6, Properties and Attributes of Polygons. Today we're going to classify polygons based on their sides and angles, and also find and use measures of interior and exterior angles of the polygons. So, first of all, a couple of vocabulary. So here I have a polygon, and the polygon, notice it has all the side lengths are segments, and there's nothing overlapping, and they're also, it's all closed. There isn't any open segments that create any open space. So some vocabulary, a side of a polygon is a segment that forms the polygon. So for example, this side right here, AB, is a side. We also have side BC and side CD and side DE and side EA. Okay? Also, a vertex of a polygon is the common endpoint of two of the sides. So like for example, this is a vertex, point C. A and B are also vertexes, D is a vertex, E is a vertex. A diagonal is a segment that connects two non-consecutive vertices. So, for example, AD is a diagonal. Okay? So, a couple of other vocabulary. A regular polygon is when all the sides are congruent and all of the angles are congruent. You'll notice that this is not a regular polygon up here. Your construction project you've been doing, you've been making regular hexagons and regular pentagons and regular hexagons. Those are all regular, okay? But this one up here is irregular. Concave and convex. If a diagonal is drawn outside of the polygon, then it's concave. If it's drawn, all the diagonals are drawn inside of the polygon, then it's convex. So, for example, here is an example of a concave polygon. You'll notice that I can draw this diagonal here outside of the polygon, so it is concave. It also, people think, okay, it caves in. Okay, so that is concave. An example of a convex polygon would be this, in which all the diagonals are inside the polygon. There is no diagonal that's outside of the polygon, so it is convex. Okay? Now, before I show you the answers to these, let's see if you can turn off or pause your video and see if you can come up with these on your own. See how many you remember. So go ahead and pause it. Okay, did you pause it? All right, we're back now. So the number of sides. So a triangle is 3. A quadrilateral is 4. Pentagon is 5. Hexagon is 6. Septagon is 7. Octagon is 8. Nonagon is 9. Decagon is 10, and dodecagon is 12. How many did you get? Did you get them all? I'd be impressed if you did. Very good. And if anything beyond 12, there are names for them, but we're not going to bother learning them because it gets a little bit crazy. So we're just going to call all the rest of them n-gons. So if it's for example, 13 will be a 13-gon. 14 would be a 14-gon. And so all the rest of them will just be the number and then gon after it. Okay? So now let's talk about what the angle measures of all of these polygons are. So if you have a triangle, how many sides does a triangle have? Well, it has 3 sides. And how many triangles are made inside this triangle? Just 1. And what is the sum of the interior angles? 180. Right? We already learned that, the triangle sum theorem. How about a quadrilateral? Well, there are 1, 2, 3, 4 sides. And how many triangles? If I were to draw a diagonal, I would get this triangle and this triangle, so that's 2. And so how many, each triangle is 180, right? So it's 180 times 2, which is 360 degrees. These should be degrees. So pentagon, how many sides does a pentagon have? 1, 2, 3, 4, 5. If I were to draw on diagonals, I would get how many triangles? 1, 2, 3. And so then it would be 180 times the 3 triangles now, which is 540. How about a hexagon? Hexagon is 6, right? 1, 2, 3, 4, 5, 6. How many triangles can I draw from a hexagon? So there's, if I draw these 3 diagonals in, 1, 2, 3, 4. And so that's 180 times 4, which is 720. So does anybody see the pattern? If you see the pattern, you'll notice that how do we get from the number of sides to the number of triangles? How did we get from 3 to 1 and 4 to 2 and 5 to 3 and 6 to 4? Would you agree that we subtracted 2 every time? So if it's any size polygon, n, to find out the number of triangles, it's going to be n minus 2. Now, what did we do over here? Well, we took how many triangles there were and multiplied it by 180. So this is 180 times n minus 2. That's the pattern. And that's exactly what we write on here. The sum of all the angles in a convex polygon is n minus 2, that's the number of triangles that you can form from it, times 180 degrees. Okay? Also, if you look at the exterior angles, so let's draw a polygon over here. I'm just going to do a quadrilateral. If I were to add up this angle, and this angle, and this angle, and this angle together, I would get 360 degrees. And all polygons work that way. If you add up their exterior angles, you're going to get 360 degrees. So here are the formulas. If you are finding the sum of the measures, you're adding them all up for the interior angles, it's going to be n minus 2 times 180 degrees. If it's the exterior, they all add up to 360 degrees. Now, if you're trying to find one angle measure of a regular polygon, you take this sum, n minus 2 times 180, and you divide it by how many sides there are, which is your n. Okay? And that only works for regulars. And if you have a regular polygon and you're trying to find one of the exterior angles, you do the same thing. You do 360 divided by the number of sides that there are, which is your n. So let's do 3 examples. The sum of the interior angles of a convex octagon. Octagon means 8, right? Octopus has 8 legs, so octagon. So we're sum, so that's all of them together. So we have n minus 2 times 180 is our formula, so we're going to plug in 8 for our n. So 8 minus 2 times 180, so that's 6 times 180, which is, no, 8 minus 2, so 6 times 180, let me, which is 1080 degrees. So that's my answer here. Okay? Now we're having one interior angle of a regular nonagon. So non is 9. So this time we're only finding 1. So n minus 2 times 180 divided by n is our formula. So we're going to plug in 9. So 9 minus 2 times 180, and then divide it all by 9. And that is going to get you 140 degrees. Okay, and now if we're trying to find an exterior angle of a regular hexagon now, we're going to take 360 divide by how many sides there are, n. So that's going to be 360 divided by hexagon is 6. So divide by 6 and you get 60 degrees. Okay, and that's how we find those three. All right, have a great day. See you next time.